Today we're going to learn how to solve linear systems by using a method called elimination. In this first example, you'll notice that each of the equations are already set up in the same exact order. The x is first, the y is second, and the constants last. This is important for elimination because we're going to add the two equations together, and we're hoping that one of the variables will eliminate or go away. In this case, it is an automatic elimination, and I can see that because when I compare my x terms, they're the same exact number, but they have opposite signs. So I'll go ahead, draw a line, and I'm going to add each term directly down. -3 and +3 is a 0x, which means I do not need to write it. 1y and 4y is 5y. -24 and +24 is 0. To solve for y, since y is multiplied times 5, I'll divide by 5. 0 divided by anything remains 0. So, the point where these two lines will cross has a y value of 0. In order to find the x value for this point, I'm going to take that y value and I can plug it into either one of my original equations. It really doesn't matter which one. So I'll take y equals 0 and I'll plug it into this first equation. That gives me -3x plus 0 equals -24. Now, I don't need the 0, so it's really just -3x equals -24. To solve this equation, since x is multiplied times -3, I will divide by -3 on both sides. So x is equal to a +8. So the point where these two lines cross is 8, 0. In this second equation, you can see they've already lined everything up properly for me. And I do have the same number in both of my x terms, but they are not opposite signs. So if I added them together, they would not eliminate. They would actually become a larger number. We can fix this problem easily. All we have to do is multiply one of our equations by a -1. So I'm going to keep the top equation the same, 10x minus y equals 24. And my second equation is going to become -10x, -7y equal to +8. Now I can add the two equations together and the x terms will eliminate. When I add -y and -7y, I get -8y. And 24 plus 8 is 32. To solve for y, since it's multiplied by -8, I will divide -8 on both sides. So y is equal to -4. Now, just like before, this only gives me part of my answer. I have the y value. I need to find the x value. I have a lot of options. I can take that y value, and I actually have 4 different equations that I could plug into. Actually, these top 2 are the same. But I can choose from one of these equations, and it doesn't matter which one. So I'll just choose this first equation. 10x minus y, which is -4, equals 24. My double negative becomes a positive. I want to solve for x, so I'll start by subtracting 4 on both sides. That gives me 10x equal to 20. Now I'll divide by 10, so x is equal to 2. So the solution to this system is 2, 4, -4. In example 3, again, I'm going to compare term by term. They are in the correct order, but none of my coefficients are the same. So they're not going to automatically eliminate, and I can't just multiply by a -1. I'm going to have to be a little bit more creative. I do want to talk to you about the fact that you have options. You get to choose. Do you want to eliminate the x's or do you want to eliminate the y's? Based on your choice, it's going to determine what you multiply by. In this case, I have a negative 10. I would need this top number to be a positive 10. So I would multiply equation 1 by negative 2, which would create a positive 10. That would eliminate my x's. If I want to eliminate the y's, this top number is a negative 6. So if I could make the bottom number a positive 6, they would eliminate. To do that, I would multiply everything in equation 2 by a 3. So you could just get to choose. I think I'm going to eliminate the y's because they already have opposite signs. So I will multiply equation 2 by 3. You need to make sure that you distribute it to all three terms. So equation 1 is going to stay exactly the same. Equation 2 will become negative 30x positive 6y equal to negative 12. Now we will add the two equations together. That gives me negative 35x equals negative 35. To solve for x, I'll divide both sides by negative 35. So x is equal to a positive 1. Now that I have my value for x, I can plug it back into one of my original equations. It doesn't matter which one. So I think I'll just plug it into the first one. That would give me negative 5 times 1 minus 6y equal to negative 23. Negative 5 times 1 is just negative 5. To solve this equation, I will add 5 to both sides. So I've got negative 6y is equal to negative 18. Now, to solve for y, since it's multiplied by a negative 6, I will divide both sides by negative 6. Final answer is y equals positive 3, which means the point at which these two equations cross is 1, 3. In example 4, you'll notice that the x's and the y's are lined up correctly and the coefficients also, but nothing is the same. And these numbers don't even divide into each other. So this is an example where we will have to multiply both the top equation and the bottom equation by a number in order to make them the same. You can choose again, do you want to eliminate the x's or the y's? I'm going to choose the x's. How could I make 9 and 7 into the same number? I could actually just multiply the top by 7 and the bottom by 9. That would create a positive 63 in the top and a negative 63 in the bottom, and then they will eliminate. Don't forget, whatever number you choose has to distribute to all three terms. So the top equation is going to become positive 63x, positive 49y, equal to 182. The bottom equation will become negative 63x, negative 54y, equal to negative 207. Now it's time to add the two equations together. The x terms are going to cancel each other out. When I add the two y terms together, I get negative 5y. And when I add negative 207 and positive 182, I get negative 25. Now we can divide both sides by negative 5. Y is equal to a positive 5. I'll take this value of y and I can plug it into any of the original equations. Doesn't matter which one. I probably won't choose these two new equations because the numbers are much larger. So I'll choose one of the originals. I think I'll just do the top one. 9x plus 7 times 5 equals 26. 7 times 5 is 35. I'll subtract 35 on both sides. So 9x is equal to negative 9. And when I divide by 9, I get x equals negative 1. All right, in our final example, we actually have 3 equations, which means we have 3 variables to solve for. The answer for this is also a point. It's a point in 3-dimensional space, and it will be written x, y, and then z. In order to do this type of elimination, you're going to want to look at your equations 2 at a time. And you are going to want to look for things that could possibly eliminate in an easy fashion. Like for instance, if I was to add these 2 equations together, the 5z's would automatically eliminate. So let's do that. If I add these 2 together, I'm going to get a negative 3x, and I will get a negative 4y. The z's will go away, and it will be equal to 12. Now I have to choose 2 more equations that I could add together. I could also add the top equation to the bottom equation, and you can see the 5z's are going to eliminate in these 2 equations. So let's do it term by term. X plus x will give me 2x. Negative 6y and negative 6y will give me a negative 12y. The z's will eliminate, just like I said before. Negative 24 and positive 16 is negative 8. Now I have a problem that looks very similar to what we were solving previously. I need to pick a variable to eliminate. In this case, I think the easiest one to eliminate might be the y's. I can create a positive 12 if I multiply the second equation by a negative 3. So the first equation will remain the same. 2x minus 12y equals negative 8. The second equation will become 9x plus 12y equals negative 36. When I add these together, the y's eliminate, and I'm left with 11x equals negative 44. I'll divide each side by 11, which tells me that x is equal to a negative 4. So I have the first part of my answer. To find the y, I'll plug it back into one of these equations. It doesn't really matter which one. So I'll just pick the first one. 2 times x, which is negative 4, minus 12y equals negative 8. 2 times negative 4 is negative 8. I'm going to add an 8 to both sides. And so I get negative 12y equals 0. Divide both sides by negative 12, and I'm still going to get y equals 0. So my second answer is 0. Now that I have my x and my y, I can take both of those values and plug into any of these original equations, and I'll be able to find z. I'll just plug into the first equation. If my x value is negative 4 and my y value is 0, then I have an equation that looks like this. Negative 6 times 0 is going to go away. I'm going to write this over here. So now I have negative 4 minus 5z equals negative 24. Remember, I want to solve for z, so I'll start by adding 4 to both sides. That gives me negative 5z equal to negative 20. And then finally, I'll divide both sides by negative 5. So z is equal to a positive 4. So the point where these three lines intersect is -4, 0, 4.